This video is going to talk about Boolean Algebra. To learn in a good way the base of Boolean Algebra, first we need to understand the basic postulates. There are 6 of them. The first one talks us about general definition. It says that the Boolean Algebra is a closed algebraic system containing a set of k of 2 or more elements and the 2 operators and or. The last 2 operators are represented with the characters middle point and plus. It's important that you don't forget that it can be more than 2 elements, and these ones are normally represented with alphabetical letters, starting from letter A. Now, postulate number 2 talks us about the existence of 1 and 0 as elements of A in a set of K, where 0 is the identity element for the OR operation, and number 1 is the identity element for the AND operation. Here we have an example. If we have A plus 0, it's going to be A. And we have A times 1, it's going to be also A. The third postulate is about commutativity of the AND and OR operations. This means that you can write in a different way the operations. For example, A plus B, it can be written also as B plus A, and it's going to be the same. Also, A times B, it can be rewritten as B times A.
The postulate number 4 talks about the associative of the AND and OR operation. It established that is indifferent the way in which you group the elements in the operation. In other words, if we have an element A in addition with the result of other 2 elements B and C, we can rewrite it as the addition of the result of the sum of the elements A and B plus the element C. And it's the same for the multiplication case. The postulate number 5 is about the distribute of AND over OR and OR over AND. It says us that if we have an element A in addition to the result of the multiplication of another 2 elements B and C, we can rewrite it as the product of 2 addition A plus B and A plus C. And if we can the multiplication of an element A by the result of the addition of the elements B and C is the same that have the addition between the results of the multiplication of the element A by each one of the other elements. And finally, the postulate number 6, which establishes that for every element there exists a unique element called complement, represented in this way, such as the addition between the element and its complement is equal to 1 and the multiplication between them is equal to 0.
Now we're going to use an example to try to explain you how to use all this of the postulate that we just saw. Over here we rewrite an equation, and we're going to use Boolean algebra to simplify as much as we can. The first step is to group the second part of the equation, just that we can use the associative postulate. I'm rewriting the equation and grouping the second part. Now we're going to use the associative postulate. So the equation is going to be like this. Something very important over here is that we have assume an addition of complement to his other element, so that's equal to 1. So the second step is to use the complement postulate that we just saw, and the equation is going to be like this. As I tell you, the last addition it's equal to 1. Now we can see that the b is times 1, so we can rewrite it like this. And the next step is to use the distribute postulate. So our equation is going to be like this. Y it's equal to b plus a times b plus b complement. Now we can see that again we have a sum of complements, so this is going to be equal to 1. And we're going to rewrite it like this. Times 1. So the result is y is equal to b plus a. And that is